physical chemistry. In physical chemistry, we will go with that atomic structure. So listen, in atomic structure, so what and all we are going to discuss in that. I go with that as atomic structure. So start with, we'll discuss with the Bose theory. Then Bose theory followed by we can go with that de Broglie wavelength, and here I want to discuss in that the Bose theory. I want to discuss here as hydrogen spectrum. Hydrogen spectrum, de Broglie wavelength, and followed by finally is quantum numbers. And one more point I want added here is Einstein photoelectric effect. Look at this. There are 4 important concepts which I want to discuss today. The one will be Bose theory, hydrogen spectrum. Next I can go with that what is de Broglie wavelength. In de Broglie wavelength, what they are going to explain or discuss with that. Next is very important, photoelectric effect, and finally is what quantum numbers. So today we start with Bose theory. See, just I want to give some few the information before start the Bose theory. That means the Dalton's atomic theory, what they said, atom is indivisible. But practically speaking, atom is what? Divisible. Fine, we got that. Then the inside the atom, what is present? Electron, proton, neutron, how it is? Who explained that? That means he came J.J. Thomson. He gave the information about that. Atom is electrically neutral. In that, then we can say the positive charges are the uniformly distributed and the electrons are randomly distributed. That's what Thomson said. Thomson gave the idea atom is electrically neutral. The next scientist, who's that? The Rutherford. He came into the picture and explained that the electrons revolve around the nucleus. Circular path is called orbit in very high speed. He explains that. He introduced the concept of nucleus. Nucleus has positive charge due to protons. He gave the information, the radius of the nucleus 10 power minus 15 meter, the radius of the atom is 10 power minus 10 meter. He gave the idea. But the failure of Rutherford is what? The stability of the atom is not explained by Rutherford. Because why? In that time, any charged particle revolve at very high speed, they emit radiation. Because of emit radiation, after some time, the electron is going to fall onto the nucleus. Therefore, atom become unstable. Then the question is how the Bohr overcome Rutherford theory. That's what the Bohr took the concept of what we can say that the quantization concept. What is the meaning of quantization concept? He said very clearly that each orbit is associated with some amount of energy. In those orbits, electron revolve, they never emit, they never absorb radiation. The energy of the orbit remains constant. Such orbits are called stationary orbits. Such orbits are called what? Stationary orbits. Now look at this, what Bohr said, very simple. Now I can say what Bohr said, look at this, let us take. This is what the Bohr concept. I can say this is nucleus. Now I can say this is 1, this is 2, this is 3, this is 4. That means he said that each orbit is associated with some amount of energy. In those orbits, when electron revolves, they never emit, they never absorb radiation. The energy of the orbit remains constant. That's what he said. When I can write n is equal to 1, I can say K shell. When n is equal to 2, I can say it's called the L shell. When n is equal to 3, I can say it's called the M shell. I can say n is equal to 4, I can say it's called what? L shell. N shell. This is what Bohr given the idea. And next is he said, The angular momentum of an electron in a particular orbit is equal to mvr is equal to nh by 2 pi. I can write that. Angular momentum of electron, mvr is equal to nh by 2 pi. Now what is m? M is nothing but the mass of electron. V is velocity of the nth orbit. R is what? Radius of the orbit. Here n is integer. Now itself I'll tell you what is that. N is nothing but is a principal quantum number. H is Planck's constant. The value could be is what? I can write 6.626 into 10 power minus 34 joule second. And very important, this is how the Bohr overcomes Rutherford theory. Very simple idea. This is what we can say the first orbit, second orbit, third orbit, fourth orbit. What he says that each orbit is associated some amount of energy. In those orbits, electron revolves, they never emit, they never absorb radiation. Therefore, energy of the orbit remains constant. Therefore, the electron is not fall into the nucleus, atom is stable. Fine. The next question what they are asking, so when the electron, when what they are going to absorb the energy, when they are going to emit energy. Very simple. I can say this is 1, 2, 3, 4. I can say that. Listen. Now, I can say this is, look at this. I can say that this is n is equal to 1. I can say this is n is equal to 2. Now I can say here the electron is there. Now, the electron is excited when if absorbs energy. That means if energy is absorbed, the electron is moved from lower energy level to higher energy level. We know that the higher energy level is unstable. When they are come back to the lower energy level, they are going to emit what we can say the radiation in the form of energy. The whatever energy it is absorbed, it is going to higher energy level. The whatever energy is absorbed, when they are going to come back to the lower energy level, they are going to emit the radiation. Whatever the absorbed energy, they are going to emit in the form of radiation. Therefore, I can keep it. This is what I can write is E1. This I can write is what? E2. Now I can write is what? E2 minus E1 is equal to what we can say? H mu. Therefore, I can write that delta E, which is equal to, I can say that Hc by lambda. That's all. This is what the Bohr postulates. And another important point is said, I want to say here, I can write it. 3 points I want to repeat that. MVR is equal to N H by 2 pi. Listen carefully. What are all the postulates of Bohr's theory? Point number 1. He said it's hydrogen-like species, hydrogen atom. Electron revolves around the nucleus, circular path is called orbit. Fine. So each orbit is associated with some amount of energy. In those orbits, electrons are revolved. They never absorb, they never emit radiation. Therefore, the energy of the orbit remains constant. Therefore, electrons not fall onto the nucleus. And second is, we said the angular momentum of an electron in a particular orbit is equal to nh by 2 pi. N is what? Integer. But now itself in n is nothing but principal quantum number. And m is what? Mass. V is velocity of the nth orbit. R is radius of the orbit. We know h is Planck's constant. 2 pi is a constant value. Fine. The next question, the when what we can say electron goes excitation and when de-excitation takes place. Very simple. If electron goes lower energy level to higher energy level, absorption takes place. We know that higher energy level is unstable. When they have come back to the lower energy level, whatever the energy absorbed, they are going to emit in the form of radiation. That's the reason. The energy difference between these two energy levels, E2 minus E1 is equal to h mu. Therefore, delta is equal to hc by lambda. Fine. So from this, the Bohr has derived one big equation. From the equation, we are going only the formula. That means he given the velocity of the nth Bohr orbit for hydrogen atom and radius of nth Bohr orbit for hydrogen atom and kinetic energy of nth Bohr orbit of hydrogen atom and potential energy and total energy. Like that, he has derived. But we are discussing only what we can say the formula. The formula which is useful for the what we can say calculation purpose. Listen carefully here. Now I can write it. He has given that. Now I want to write it. Listen. I can write that velocity of nth Bohr orbit I can write it as, look at this, En 2.18 in 10 power 6. I can write that Z by N, meter per second. Now I can write radius Rn, which is equal to, I can listen carefully, Rn is equal to 0.529 to 10 power minus 10 n squared by z meter, because radius unit is what, meter. Now, very important, I am going with kinetic energy of nth Bohr orbit. I can write that 13.6 into z squared by n squared in terms of electron volt per atom. Now, potential energy, I can write that minus 27.6, 27.2 z squared by n squared in terms of electron volt per atom. Then we know that an addition of these two, which gives what, potential, that means total energy, that means kinetic energy plus potential energy, which gives what, total energy, is equal to, I can write that minus 13.6 into z squared by n squared in terms of electron volt. This is what the Bohr proves that. For example, if I am saying that, what is the velocity of first Bohr orbit of hydrogen atom? What is the first Bohr orbit of hydrogen atom? What is Z here? Z is atomic number. N is nothing but first Bohr orbit, n is equal to 1. That means first Bohr orbit means n is equal to 1. Second Bohr orbit, n is equal to 2. Third Bohr orbit is equal to 3. That means by using this, what is the velocity of the first Bohr orbit of hydrogen atom means I can write 2.18 10 power 6 meter per second. Fine. And what about that? The radius of the first Bohr orbit of hydrogen atom. What is the radius formula? We can say that Rn is equal to 0.529 10 power minus 10 n squared by z. The first Bohr orbit means what? N squared. That means n 1 squared. 1 squared means 1. Therefore, we can say the radius of the first Bohr orbit of hydrogen atom is what? We can write it as 0.529 angstrom. Now, the question I want to ask you. So, what is the radius of the first Bohr orbit of helium plus? So, what is first Bohr orbit of helium plus means what? First Bohr orbit of helium plus. That means atomic number changes, number of proton will change. That means is it nothing but is what? 2. Please keep it in your mind. When they are asking whether it is hydrogen atom or helium plus or lithium 2 plus or beryllium 3 plus, you have to think about that. Now these are all the formulas derived by Bohr. Now I am asking, what is the radius of the second Bohr orbit of helium plus? Look at this, and the question is, I am writing that, what is the radius of second Bohr orbit of helium plus? I am writing second Bohr orbit of helium plus. Yes. What is the formula? I can write that Rn is equal to, I am writing 0.529 n squared by z. I can write in terms of, this is angstrom. I am asking is what? Second Bohr orbit, I can write that 0.529 into 4 by, I can write is what? Helium. What is the atomic number of helium is 2. So I can write that 2 into 0.529 angstrom. Is the answer? That's all. This is what the examination point of view they will ask. It's a simple question. And one more thing. Now I can make one statement. Listen, I'll give one question. From there I'll make one statement. Look at this. Now, same thing. Look at that. Now, what is the radius of second Bohr orbit of beryllium 3 plus? And beryllium 3 plus. What is the radius? Rn, which is equal to, you can write 0.529 n squared by z. What I am asking, in beryllium 3 plus, what is the radius of second Bohr orbit? That means what? I can write n, which is equal to 3. I can write that r is equal to 0.529. N squared is what? 4. Beryllium 3 plus, what is atomic number is what? 4. 4 cancelled out. That means I can write that 0.529 angstrom. So what did you understand from this? Which means that the radius of first Bohr orbit of hydrogen atom is equal to the radius of the second Bohr orbit of beryllium 3 plus. Both will have what we can say same radius theoretically. This is what in exam they will ask you. Fine. Now come to the point. Next one I want to go with. What is that? Now I have given the derivation what the kinetic energy. What is the kinetic energy? I can write that E which is equal to, I can write that 13.6 into Z squared by N squared. Now what is potential energy? I can write that minus 27.2 Z squared by N squared. Now what is total energy? Which is equal to minus 13.6 Z squared by N squared in terms of electron volt per atom. Now what is my question? Sir, why sir the total energy of the electron is negative? Which means that the more and more negative value, electron is closer to the nucleus. That means more attractive force. If the electron is far away from nucleus, the attractive force is less. The electron can be easily removed. That's the meaning of the negative sign. The negative sign indicates that electron is strongly bound to the nucleus. That's what Bohr said. What Bohr said, that each orbit is associated with some amount of energy. Look at this. Now this is total energy. Now this is N belongs to what number? There means orbit. Now for this I am writing N which is equal to 1. What is total energy? For H atom. Now total energy for what we can say N is equal to 1 minus 13.6. When I am writing when N is equal to 2, I can write that minus 13.6 by 4. Now I can write when N is equal to 3, I can write minus 13.6 by 9. Look at this. This is first orbit, second orbit, third orbit. That means we can say that each orbit is associated with some amount of energy. That this is the first orbit, minus 13.6 electron volt per atom amount of energy is associated with the first orbit. Second orbit associated with minus 13.6 by 4, and third orbit is minus 13.6 by 9. That means that each orbit is associated with some amount of energy. Okay, sir. The next question. I told you that in the postulate itself. That means if supply energy, electron goes to higher energy level. And another important point I want to say here. That means when n is equal to 1, that means the energy will be more and more negative. Therefore, n is equal to 1 is called ground state. Remaining all are called what we can say excited state. That means when n is equal to 2 is called the first excited state. When n is equal to 3 is called the second excited state. When n is equal to, we can say 4, third excited state. When n is equal to 1 is called ground state. And one more thing, please keep it on your mind. Please keep it on your mind. If the energy of the electron is 0 means electron is not bound to the nucleus. Energy of electron is 0 means what? Electron is not bound to the nucleus. The electron is called free electrons. So how we are going to say, look at that. Now what that Bohr explains that, I told you. Now I can say that minus 13.6 Z squared by N squared. I have done that. Now if I am going to supply the energy to what we can say excite the electron, that means I can write this. I am giving us is what is E1 N1 squared, and writing is what E2 which is equal to minus 13.6. I can write that Z squared by N2 squared. Now what we can say, this E2 minus E1 is equal to 13.6 into Z squared. I am writing 1 by N1 squared minus 1 by is what? N2 squared. Electron volt per atom. Please look at this. I can write delta E. Delta E which is equal to, I can write that 13.6 into Z squared 1 by N1 squared minus 1 by N2 squared in terms of electron volt per atom. Please look at here, very important. Using this equation, we can able to find out the ionization energy of single electron species like hydrogen atom. How's that? What is ionization energy? The amount of energy is required to remove an electron from neutral gaseous atom. The amount of energy is required to remove an electron from its valence shell in a neutral gaseous atom is called ionization energy. That means now I can say this is hydrogen atom. I am taking. We know that the hydrogen atom which has what? It's only one electron. This is the positive charge nucleus. Now if I remove the electron, I can say that H plus electron. Now this electron is not what we can say bound to the nucleus. Therefore, this electron is a free electron. Free electron means what? The energy of the free electron is what? 0, which means as per mathematically we can say N2 must be what we can say infinite. That means now if I want to remove the electron from the hydrogen atom, or we can say the ionization energy of hydrogen atom, I want to find out means I can write delta E is equal to, I can write that, listen, 13.6 1 by 1 square minus 1 by what we can say infinite. That means I can write that 13.6 electron volt per atom. That means if I supply that 13.6 electron volt per atom, I can able to remove the electron from the hydrogen atom. That is called ionization energy. And what about the helium plus? Very simple. Same formula. 13.6 Z squared 1 by N1 squared minus 1 by N2 squared. Helium plus means what? Z squared will vary. That means 13.6 into 4. That is the ionization energy of helium plus. What about lithium 2 plus? 13.6 into 9. What about beryllium 3 plus? 13.6 into 16. That's all. This is what the Bohr's explanation about the, what we can say, the equation which gives information about the ionization energy of single electron species. Fine. Now, in the exam, what they will ask you, I want to write one question. Look at this. I want to give one question. Listen, I'm writing the question. The question is, look at that. I can write that ionization potential of hydrogen atom is 13.6 electron volt per atom. Now fine, I'm right. This is the question is the ionization potential of hydrogen atom is 0.6 electron volt per atom. And what would be ionization energy of an electron in first excited state of lithium 2 plus. This is the question. Now they are given the information is what? Ionization potential of hydrogen atom is 13.6 electron volt per atom. And what would be the ionization energy of the lithium 2 plus? The electron is present in the first excited state. So what is the formula? Look at this. Delta E, which is equal to, I can write that 13.6 into Z squared. I can write that 1 by N1 square minus 1 by what is that? N2 square. Very simple. Now my question is what? For lithium 2 plus, where the electron is present in the first excited state. Is present what we can say? First excited state. First excited state means what? N1 is equal to 2. Therefore, N1 squared is what? 4 or not. That means I can write N1 which is equal to 2. I can write that N2 is equal to what? Infinite, because this is very important. So what? First excited state of Li2 plus. I can say that N1 is equal to 2. N2 must be is what? Infinite. Therefore, I can write that delta E is equal to 13.6. Z squared is what? Li2 plus. We know that number of protons in lithium 2 plus is what? 3. Therefore, 3 squared means what? 9 into 1 by 2 squared is what? 4 minus 1 by what we can say infinite. Therefore, we can write that 13.6 into 9 by 4. If we simplify this, you may get the answer of 30.6 electron volt per atom. That's all. This is what you may expect in the examination point of view. That's all. That's all. And one more thing, the boards explain about what we can say the hydrogen spectrum. Look at this. Hydrogen spectrum. So what is hydrogen spectrum? Very simple. That is, I can take it as, see, I will take very I can say this is called, I can take it as emission spectrum also, I can say. Just I am taking here, n is equal to 1. n is equal to 2. I can say n is equal to 3. I can say n is equal to 4. N is equal to 5. I can say n is equal to 6. I can say n is equal to 7. What is hydrogen spectrum? What information he gave? Both. Or we are going to supply the energy, more amount of energy, because hydrogen has single electron. If electron goes to what we can say excited state. When it goes to excited state, obviously we know that the excited state is unstable state. But they have to come back to the lower energy level, or we can call it stationary orbits. What is stationary orbit means what? We know that what is stationary orbit means what? Those orbits, the energy of the electron remains constant. Allowed orbits. So electron has to come to the lower energy level. When they are going to come to the lower energy level, they are going to emit the radiation in the form of frequency. We know that. Now what is going to happen? For example, now that's the group of lines. Okay, for it's called the emission spectrum. So electron and the higher energy level come back to the lower energy level. All are coming to what we can say first energy level. That means I can write n1 which is equal to 1. I can write that n2 is equal to 2, 3, 4, 5, etc. This series is called Lyman series. The Lyman series where they will observe in UV region. This is called Lyman. When Lyman series means what? n1 is equal to 1, n2 is equal to 2, 3, 4, 5, etc. And this line is called, that means I can say the 2 to 1 is called first line of Lyman series. I can say 3 to 1 is called the second line of Lyman series. I can say 4 to 1 is called what we can say third line of Lyman series. The first line of Lyman series is 2 to 1. Second line of Lyman series is 3 to 1. Third line of Lyman series is what? 4 to 1, like this. And the infinite one is called limiting line of Lyman series. Suppose now the electron excited state. Now it is all is going to come back to. This is called emission spectrum. That is. Now I can write it. This series is called Balmer series. Now Balmer means what? I can write n1 which is equal to 2. I can write that n2 is equal to 3, 4, 5, 6, etc. etc. This is called Balmer series. Lyman, this is called Balmer. Where they are observing visible region. So visible region means what? This is called VIPGYOR. 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 That's all. This is VIPGYOR is increasing order of lambda. Therefore, the first line is belongs to red region because energy transition is less. Wavelength is high. We know that E inversely proportional to wavelength. Therefore, the first line is belongs to, we can say, red region. But that means I can say first line of Balmer series means what? I can say this is 3 to 2 is the first line of Balmer series which is observed in the visible region. In Balmer series means what? n1 is equal to 2, n2 is equal to 3, 4, 5, 6. In Lyman series means n1 is equal to 1, n2 will be 2, 3, 4, 5, 6, etc. Fine. Now come to the point in this case. Now Lyman, Balmer, you can say it's a Paschen series. Same thing. In Paschen, you can say n1 is equal to 3, which is observed in the IR region. And same thing, now look at this. I can say here, Lyman, Balmer, Paschen, this is what? Bracket series. n1 is equal to 4. Bracket series, Lyman, Balmer, Paschen, bracket series when n1 is equal to 4. Now come to the point. Now look at this. N1 is equal to 5. And this is called fun series. So all these three will be observed in what? Yeah. This is how they are finding out the ideal spectrum experimentally. Lyman, Balmer, Paschen, Brackett, and fun series. Fine, we have learned. கண்டுபிடிச்சாச்சு. இதுக்கப்புறம் என்ன பண்ணுவோம்? எக்ஸாம் எப்படி கேட்பாங்க அப்படின்னா, suppose electron, if it's in the fourth excited state, how many spectral lines are observed? The electron in the four hydrogen spectrum, electron which is present in the fourth excited state, find out how many spectral lines are observed. How many spectral lines are observed? What is the meaning of that? Look at this. Now, so look at this. Now, you can say this is 1, 2, 3, 4, 5. What they said? Electron which is present in the fourth excited state. What is the meaning of fourth excited state? Fourth excited state means what? The electron present in the fifth energy level. Here electron is present. Now they are asking you to find out, because you know that higher energy level unstable. So they have come back to the lower energy level. And the energy emission is what? Discontinuous. So what is discontinuous? That means, look at this. It may go to what? 5 to 1, or I can say it is 5 to 2, or it may go to 5 to 3, or I can say it is what? 5 to 4. Or, look at this, or it may go to what? 4 to 1, or you can say that 4 to 2, or I can say is what? 4 to 3. Or look at this, it may 3, it may go to 3 to 1, or it may be 3 to 2, or finally is what? As 1, 2, 3, 4, 5, 6, 7, 8, 9. You're observing is what? 10 spectral lines. In 10 spectral line, how many lines are belongs to Lyman series? Lyman series means what? 1, 2, 3, 4. Lyman series means N1 is equal to 1. Therefore, we got 4 belongs to what? Lyman. Then how many lines are belongs to Balmer? And how many lines are belongs to Lyman, Balmer, Paschen? Then one will use what? Brackets here. That's all. This is what the examination point of view they will ask you. And one more thing. So can you able to find out the frequency of the first line of Lyman series? Why not? Definitely we can able to find out. So can you give me the example how to find out the wavelength of the first line of Balmer series? Yes, we can able to find out by using the Bohr's equation. Look at this. What is the Bohr's equation? Yes, known as delta E, which is equal to written as 13.6 into z square, and that is what? 1 by n1 square minus 1 by n2 square. So we can say always n2 is greater than n1. Okay, n2 is final state, n1 is what? Initial state. That also we can say. Now delta E is what? hc by lambda. I'm writing that 13.6 into z square, I'm writing 1 by n1 square minus 1 by n2 square in terms of electron volt per atom. Now I want to convert electron volt to joules, means multiply the charge of electron. 13.6 into 1.6 in 10 power minus 19 by 6.626 in the 10 power minus 34 3 into 10 power 8. It's the velocity of light. 1 by lambda is remaining will be z square 1 by n1 square minus 1 by n2 square. In terms of you are going to get lambda, so you are going to get as a per meter you will get it. If I simplify these values, I can write that 1.01 into 10 power 7 z square 1 by n1 square minus 1 by n2 square per meter. This is inverse of lambda is called the wave number. So this is called as RH is called Rydberg's constant. Rydberg constant. That means we can write as a wave number is equal to, I can write that RH is z square 1 by n1 square minus 1 by n2 square in terms of per meter. So this is what the board explains about the hydrogen spectrum, the emission spectrum. We can able to find out the wavelength. Can you solve one question based on that? Look at that. The question is, I'm going to write the question. The wavelength of first line of Lyman series is, I'm writing the question is, the wavelength of first line of Lyman series of hydrogen atoms X angstrom, we can keep it. Okay. Now, then what is the wavelength of second line of Balmer series of helium plus ion? Express the answer in terms of angstrom. Now repeating the question. Look at this. The wavelength of first line of Lyman series of hydrogen atom is X angstrom, and find out the wavelength of second line of Balmer series of helium plus ion. Now I can write it. Look at the solution. How to solve the problem? I'm writing 1 by lambda of hydrogen is equal to, you can write that RH into Z square. So what is given as Lyman series of first line? First line means what? N1 is equal to 1, N2 is equal to 2. Now I am writing 1 by 1 square minus 1 by 2 square. I can write that 1 by lambda of helium plus is equal to, I can write it as RH into Z square. Now the question is, what is the wavelength of second line? Second line means what? For Balmer series. Look at this. Second line Balmer series. Second line of Balmer series means what? N1 is equal to 2 square minus, you can say the second line. That means I can write as a 4 square. Now what is going to happen? We are going to get as RH and RH cancelled off. What is Z squared in the case of here? The helium plus. Therefore, we are going to get Z squared. Z is what? 2. 2 squared is what? 4. Z squared for hydrogen atom is what? 1. Therefore, we are going to get it as lambda of helium plus by, we will be getting lambda of hydrogen, which is equal to 3 by 4 by, we are going to get 4 into, we will be getting as 1 by 4 minus 1 by 16. Now if I take it inside, which I am going to get it as 3 by 4 by I'm going to get as 4 if I go inside, 4 by 4, 1 minus, I can write that, 1 by 4, therefore lambda of helium plus by, this value is given as, x is given, is equal to, I can write it as, therefore 3 by 4, 3 by cancel off, therefore lambda of helium plus is equal to x. I'm strong only. So from this, what do we understand? Please understand from the question. We can learn the theory part. What's that? That means the wavelength of the first line of hydrogen atom is equal to the wavelength of second line of helium plus. This statement is right. Look at this. Repeating again. The wavelength of the first line of Lyman series of hydrogen atom is equal to the wavelength of second line of Balmer series of helium plus. Both have the same wavelength is the correct statement. This is what in the examination they will ask you statement. Right? So now next is another important point I want to say, that there is a big drawback of Bohr. What is the big drawback? Because he has not able to prove that MVR is equal to NH by 2 pi. No, the proper proof is not there. And he consider only for the single electron system. And they are asking about that he considers here as a particle character, but electron has a dual character. And there is a contradiction between Bohr's and Heisenberg's. What is the contradiction? See, he said such a microscopic particle, he said the exact position and velocity, which is impossible. You cannot able to find out for microscopic particles simultaneously position as well as momentum, which is impossible to find out. Then what do you have to do? That means we can go only with the probability of finding electron density is maximum. That region is called orbital. That means shell has subshell has orbitals called quantum numbers. Right? The Bohr not able to explain, because the Bohr considers only the particle character. And another important point is what not able to explain, that how did you say that position and velocity you have determined exactly and simultaneously, which is not possible, such a microscopic particle. It's impossible. Then what they are bringing the concept of quantum numbers. So before going quantum numbers, how the de Broglie has explained the dual character. Very simple. See, what de Broglie said, the every object in motion, they produce wave. And the wave measure panna mudunja, that behave as a wave character. If the measure panna mudilaya, tough to measure, that behave as a, what we can say, particle character. That's what he gave the equation. Look at this. Let us consider the de Broglie wave equation. De Broglie equation, he has taken lambda is equal to, I write h by mv. So how he brought it? Very simple. He has taken E is equal to hc by lambda, and E which is equal to what we can say mc square. So he has taken these two equations and he has given this equation. Here V is what? Velocity of the moving object, and m is what? Mass of the object. That means if the lambda is measurable for any moving object which behaves as a wave character. For example, I am taking one simple example. Look at this case 1. I am taking tennis ball. I am taking this one, tennis ball. Okay, this is the case 1. Moving the speed of, I can take 10 meter per second, and mass of the ball is what? I can say 100 gram. So I can say that mass of tennis ball is moving, mass of tennis ball 100 gram. The moving the speed of 10 meter per second. Find out the wavelength of this. I can write what is the equation? Lambda, which is equal to 6.626 10 power minus 34 by the mass in terms of kg. We have to take it because then only the dimension will be cancelled out. Therefore, I can take 0.1 kg into 10. So now what is the answer? Lambda which is equal to 6.626 10 power minus 34. meter. So which is negligible. Therefore, the tennis ball behaves as a particle character. But if you take the electron, so the mass is going to come as what? 9.2 10 power minus 31. If we take the velocity of the first Bohr orbit is 2.18 10 power 6. You're able to find the lambda. The lambda is measurable. It will come approximately 1 Armstrong. Therefore, the de Broglie wave equation is only applicable for microscopic particle. For electrons, such as electron is what we can say, obey that. Then how he has proven that 2 pi r is equal to n lambda? Look at this. Now, I am going to that. Now, listen. Now, this is the orbit. I told you electron has the wave character. And the electron is revolves. Look at this. This is called the circumference of the orbit. Fine, this is the wave. This is one wave I can say, this is also wave. Now what de Broglie said, the circumference of the orbit is equal to what we can say, n lambda, or we can say integral multiple of wavelength. I can write 2 pi r is equal to what we can say, n lambda. This is the stable wave. The any wave which produces in the particular orbit has to obey this equation. 2 pi r is equal to n lambda. Now look at this. What is lambda? You can say 2 pi r is equal to n h by m. Now I can write that mvr is equal to n h by 2 pi. Means whatever the Bohr said is right. mvr is equal to nh by 2 pi. It's called the quantization of the angular momentum of an electron particular orbit. Yes, it is right. But the Bohr did a mistake is what? He took it as a particle character. But de Broglie said it's a dual character. When behave as a wave, it produces 2 pi r is equal to n lambda. Why integral multiple of wavelength? From this, we can able to find out the number of wave produced particular Bohr orbit is equal to principal quantum number. So how's the number of waves produced particular Bohr orbit is equal to principal quantum number? How? Look at this. I'm writing number of wave produced particular Bohr orbit is equal to principal quantum number, nothing but circumference by what we can say lambda, which gives a number of what we can say number of wave produced particular Bohr orbit. We can write that 2 pi r is nothing but n h by mv by what is lambda? H by mv cancelled off, which is equal to n. N is called principal quantum number. That means number of the wave produced in particular Bohr orbit is nothing but the principal quantum number. Right? And one more thing, in the calculation point of view, for especially for de Broglie wave equation, you can take it as lambda is equal to h by mv. This lambda for what we can say any moving object. Any moving object. Right? So lambda is equal to h by mv. V is what? Velocity of the object. From this we can derive that. Look at this. Now I can write that Ke is equal to half mv square. Therefore, v square is equal to 2Ke by m. V is equal to root of 2Ke by m. Therefore, substitute that lambda, which is equal to h by root of 2 into Ke into m. That's all. This is what the problem purposes. From this, please understand kinetic energy. Kinetic energy of the object depends on temperature. Therefore, lambda also depends on temperature. Therefore, frequency also depends on temperature. That's what the Planck theory said that. That is the kinetic energy, wavelength, and frequency. They are temperature dependent. Right? Please note, this is very important. So, from this in exam, what they will ask you. In exam, what they will ask you, look at that. Now, in exam, if the first Bohr orbit of hydrogen atom, the radius of I can say, okay, the first Bohr orbital hydrogen atom S A naught. Find the de Broglie wavelength. Find the de Broglie wavelength of electron in third orbit of helium plus. They gave the option, ordered option. I can go with that. Options are A 2 pi R naught. That means A naught. B 3 pi A naught. C 9 by 2 pi A naught. And D 6 pi A naught. This is what the question you may expect for the JEE mains. The first Bohr orbit of hydrogen atom is A naught, or we can say the wavelength of the first Bohr orbit of hydrogen atom is A naught, and find the de Broglie wavelength of the electron in third Bohr orbit of helium plus ion. So how to solve this question? Options are 2 pi A naught, 3 pi A naught, 9 by 2 pi A naught, D will be 6 pi A naught. How to solve this question? We know that what is the condition for stable wave? 2 pi r is equal to n lambda. You can write that 2 pi r, which is equal to, you can write n lambda. Now what do you want to find out? Lambda only you want to find out. Now we can write r is what? We can write 2 pi. I am taking r, you know the formula, 0.529 into 10 power minus 10 n squared by z. That 0.529 10 power minus 10 I am keeping as a naught n squared by z, which is equal to n lambda. Therefore, this n and this n will be cancelled off. What is z for helium plus? Therefore, 2 pi A naught. Now, 3 will be there by, and write 2, which is equal to lambda. This 2 and this 2 will be cancelled off. Therefore, I can write lambda is equal to 3 pi A naught. This is what they will ask you in the physical chemistry. They may interlink the questions. And one more question they will ask you. Look at this. I'll give one more question also. Find the kinetic energy of, look at this. This question very important question. You may expect such questions in the examination. They will ask you find the kinetic energy of second Bohr orbit of hydrogen atom. Look at this. I am writing and give the option also. I can write, listen to kinetic energy of, and write second Bohr orbit of hydrogen atom. You keep it as A naught is Bohr radius. I am writing option A. Square 16 pi square m A naught square. Option B, h squared by 32 pi square m A naught square. Option C, h squared by 64 pi square m A naught square. Option D, h squared by 8 pi square m A naught square. This is what the options were given. They're asking the kinetic energy of second Bohr orbit of hydrogen atom is. That's a question. How to find out it? Look at this. Now I am going with that. How to solve this one? We give direct equation, but how we have to solve? You have to get the idea. Look at this. Now I'm going. We can say that K which is equal to, we can write half m v square. K is equal to half mv square. We want to find out that v square. I am writing mvr which is equal to, we can write n h by 2 pi. Now what is v square? V squared is nothing but, you can write m squared h squared by m squared into what? R squared into 4 pi squared. This is v squared. Fine. And what is r squared? Very simple. I am writing as r. We can take it as, I am taking a naught n squared by z squared. R squared which is equal to, you can take a naught squared into n power 4 n square by z. Now this will be z square. Now substitute here. I can write it as v squared which is equal to n squared h squared by, you can take it as here 4 pi squared m squared. What is r squared? You can take it as here a naught square n power 4 by into, I can write z square. Anyway, hydrogen atom z square is not required because z square is nothing but is what? 1 only. Now I can write that v square is nothing but, I can write it as h square. This and remaining what? H square by 4 pi square. I can write it as m square, a naught square, n square. This is what we got it. This is v square. Can I substitute in this equation? I can write it as Ke which is equal to what? Half me square. Half m is what? V squared. This and this will be cancelled off. Therefore, h squared by, I can write it as 4 pi square m a naught square. What is n square? They gave second Bohr orbit. That means I can write 4. And what is the answer? The answer could be 4 into 4, 16. 16 into 2 is what? 32. Therefore, h square, 32 pi squared m a naught squared is the answer. That means I can write kinetic energy is equal to, we can write that h squared by 32 pi squared m a naught squared. That's all. This is what you may expect in JEE Minds question. So this is the question. Kinetic energy of second Bohr orbit of hydrogen atom. A naught is Bohr radius. Look at this. Options are given. So option B is the correct answer. Fine. That's all. That's all. And one more question. I want to give you that. Listen. Now one more question. Then we'll go for the quantum numbers. What is the question is? The angular momentum of an electron. The angular momentum of an electron. I'm writing that. I'm writing. Angular momentum. Angular momentum. Momentum of an electron in helium plus S 3 point, and write that 3.1652 into 10 power minus 34 kg meter squared per second. Per second. The question is, find the wave number. Find wave number in terms of RH, in terms of RH, in terms of RH of the spectral line emitted from this state to first excited state, from this level to first excited state. This is the question. What they are asking? The angular momentum of electron in helium plus is 3.165 to 10 power minus 34 kg meter square per second. Find the wave number in terms of RH of the spectral line emitted from this level to first excited state. So we know first excited state means what? N2 is equal to 1. Extremely sorry. N1 is equal to 1 because we don't know what is the N of what we can say helium plus. I want to find out it. So now look at this. Wave number is equal to RH Z squared 1 by N1 square minus 1 by N2 square. That means obviously is what? N2 greater than N1. Obviously N1 is what? First excited state. Therefore N1 is equal to 2. Then I want to find what is N2. How I am going to find out it? Using the Bohr's angular momentum quantization condition. We can write that MER is equal to N H pi 2 pi. Now what is MER is given 3.1652 into 10 power minus 34 by, I can take 2 into pi value, we can say 3.14. I can take H value is what? 6.626 in 10 power minus 34 is equal to N. Cancel out. Now if I simplify that, approximately 6.626, 339 and 18. So N value is going to come approximately is what? 3 is going to come. Now I want to find out wave number. Z squared is what? In the case of helium plus Z squared is equal to 4. Therefore I can write that wave number is equal to RH into 4. I can take it as 1 by, because first excited state which is given here, therefore I can write 1 by 4 minus 1 by, this is nothing but the N is equal to 3. It's a second excited state, it's 9. Now wave number which is equal to RH. Now I can cancel out this, I can clear this. Now I can write it as 4 into 5 by 36. Therefore we can write it as RH is equal to, what we can say answer will be 5 by 9. That's all. Clear, children? Understand? So now come to the point. Next you want to go that. Now orbital. See what the Heisenbergs and de Broglie explained that orbital has subshell. That means extremely sorry. Orbit has principal shell. Orbit has subshell. Subshell has orbital. In that orbital, that means what is the definition of orbital? Where the probability of finding electron density is maximum, that region is called orbital. Fine. That there are 4 important principal quantum numbers. See what quantum numbers talks about that. The quantum numbers which gives information about address of electron. See where I am staying. Suppose for example, I am staying in Chennai. Is the principal quantum number. In Chennai, I can say Nungambakam is the azimuthal quantum number. In Nungambakam way, it's a first lane. In first lane, where it is, you can say Sri Mitai. That's all. Same thing for the electron. So we can say in that 2s electron in 2, that means n is equal to 2. In s means L is equal to what? 0. S subshell. In S subshell where? In that orbital. For example, 2p. 2p means what? We can say 2p, the 2px, 2py, 2pz. Are you able to follow? That is what the principal quantum number which gives information about address of electron. It's like address. There are 4, what we can say, the important principal quantum number. And please keep it in your mind. Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. There are the quantum mechanical treatment explains only the 3 quantum number. That means principal, azimuthal, and magnetic. The spin quantum number is not explained by quantum mechanical, that is explained by spectroscopic method. It is not required now, just keep it in your mind. So now I am writing that N, L, ML, and what is that? MS. What is N? Is called principal quantum number. What is N? Is called azimuthal quantum number. What is M? It's called magnetic quantum number. And what is MS? It's called spin quantum number. Listen carefully. Principal quantum number which gives information about the energy of the shell, energy of the orbit. That means Bose talks about only orbit. Talks about only orbit, energy of the orbit. And what is azimuthal quantum number? Which gives information about in which subshell where the electron is located. That means shell which has subshell. The subshell which gives information about the shape of the subshell. That means S subshell, P subshell, D subshell, and what we can say F subshell. S, P, D, F. S is spherical shape, P is dumbbell shape, and D is double dumbbell shape, and F is diffuse shape. It's very tough to draw in 2 dimensions. And magnetic quantum number which gives information about the orientation of the orbital. And spin quantum number talks about the magnetic moment of the substance. Because of the unpaired electron, it shows what we act as a magnet. That means the electrons are, if any ions or molecules or compound, if you are going to keep it in the external magnetic field, because of the unpaired electron, if they are attracted, the substances are called paramagnetic substances. If they are repelled by the external magnetic field, they are called diamagnetic substances. So from the magnetic spin quantum number, we can able to find out the magnetic moment of the ions. That means formula is root of n into n plus 2 d. What is this? N is nothing but number of unpaired electrons. So now, principal quantum number, it talks about shell. Azimuthal talks about shell which has subshell. In subshell in which where electron is located. And the subshell has orbital. Subshell has orbital. In that what we can say the electron is there. That is nothing but spin quantum number is not explained by quantum mechanical treatment. That is explained only spectroscopic method. So this formula for the magnetic moment of the particular ions or species, root of n into n plus 2 Bohr magneton. So n is here number of unpaired electrons. Okay, sir. We have learnt about what we can say the quantum numbers. Now the filling of the electrons for the multi-electron system. Please keep it in your mind. I am going one by one. Now, easy to understand. Please keep it in your mind. I am writing. When n is equal to 1, what about the L value? I can write L which is equal to 0. When L is equal to 0 means we can say that is called S sub shell. When S sub shell, we can write that ML is nothing but plus or minus N including 0. Therefore, ML which is equal to 0. That means which has only one value. S sub shell has only one orbital. Now, how come to the point? When N is equal to 2. Obviously, what N value is what? 0 and 1. When L is equal to 0 means what? S sub shell. When N is equal to 1 means what? It's a P sub shell. So P sub shell means I can write, look at this. ML is nothing but plus 1. I can write as minus 1, 0, plus 1. So I can say that the P sub shell has 3 orbitals. What is that? I can write that's all. I can say that this is PZ orbital, this is PY orbital, this is what PX orbital. That means when n is equal to 2, we have the 2 subshells. The 2 subshell has 4 orbitals. That means S orbital and 3 P orbitals. Am I right or not? That means the n squared, which gives the number of orbitals. Therefore, n squared, 2 squared, we have that S orbital 1 and 3 P orbital. So 3 plus 1 is equal to 4. Now look at this. I am going with that when n is equal to 3 means what is the L value? We can say that 0, 1, 2. So now when we can say that when n is equal to 0 means S sub shell has only one orbit because it has only one value. This has 3 values. Now I can say when n is equal to 2 means we can write that n1 is equal to, we can write minus 2, minus 1, 0, plus 1, plus 2. We have the 5 values are there. 5 values means what we can say? 5 d orbitals are there. We have the 5 d orbitals. What and all that? 5 d orbital means we can write it as dxy, dyz, dzx, dx square minus y square, and dz square. That means these 3 orbitals are between the axis. They are double dumbbell shape. And this will be what? Align the axis. That's all. 2 orbitals are what we can, these 3 are between the axis dxy, dyz, dzx, but these 2 are what we can say along the axis. Fine. Now we are going with the filling the orbitals. What is the principle? Is called Abba principle. Abba principle is only applicable for multi-electron system. Don't forget about it. Now we are going with that. Listen. I'll go 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4b, 4f, 5s, 5p, 5b, 5. So here 1, 2, 3, 4, 5, nothing but n is equal to. Now for Abba principle talks about that n plus n. For multi-electron system, energy depends on n plus n. For single electron system, energy depends on principal quantum number. For hydrogen atom, energy depends on principal quantum number. For multi-electron system, energy depends on n plus l. That means 1, yes, that means you can say this is n is equal to 1. This will be what? L is equal to 0. Therefore, 1 plus 0, 1. Here, 2 plus 0, 2. Therefore, the electron is going to fill. If the n plus L is lower value, the electron is going to fill in the lower energy level, then only go to for higher energy level. Therefore, this is 1s filled first. Then 2s. Fine. Now, if we take 2p and 3s, if 2p and 3s, you are going to get the n plus L value same. Why? P means L is equal to 1. So 2 plus 1 is equal to 3. Here 3 plus 0, 3 plus 0 is equal to 1. So obviously what will happen? 2p and 3s, that means electron where it is going to fill first? if n plus l value is same, we have to go with the principal quantum number. The lower principal quantum number is lower energy level. I can say that 2p is the lower energy level, then what we can say 3. Therefore 2 is n, here 2 for n, here is what n is equal to 3. Therefore fill 2p and 3s. Then 3p, 4s, then what we can say 3d, then 3p, and what like this is goes. That's all. That means in exam what they will ask you, if I am giving s 2p, 3s, 3d, 4s, like that they are giving. Arrange increasing order of energy level. So what you have to go n plus l value. That means I can say 2p also 3, 3s also n plus l is equal to 3. Go with the principal quantum number. Therefore 2p is the lower energy level. Then 3s. Then go with the 3d and 4s. 3d and what? 4s. So what you are going to get it? 3d means what? 3. 3 plus 2 is what? 5. Here 4 plus 0, 4. Therefore we can write 4s. And what we can say as 3d. This is what they will ask you. The examination point is called Aufbau principle. And next is very important, Pauli exclusion principle. What is Pauli exclusion principle? That means orbital can accommodate only 2 electrons opposite spin. Orbital can accommodate only 2 electrons with opposite spin, or we can say that no an atom can have all set of 4 quantum numbers. No 2 electrons can have all set of 4 quantum numbers. How's that? Look at this. Look at this now. And I'm taking as, just I'm taking, this is 2 electrons. I'm taking as a what? As 2p. For this electron, n is equal to, I can take it as here 2, n is equal to 1. M also I'm taking is what? Plus 1 I'm taking. And but ms is what? Plus of here n is equal to 2 is equal to 1. ml is equal to what? 1. But ms is what? Minus 1. That means no 2 electrons can have all set of 4 quantum numbers. That means the orbital can accommodate only 2 electrons with opposite spin. S orbital can accommodate 2 electrons, but P subshell 6 electrons, D subshell 10 electrons. Why? D subshell has 5 orbitals, each orbital 2 electrons. D orbital 2 electrons, F orbital 2 electrons. If I am using the word is orbital, they accommodate only 2 electrons with opposite spin. In the exam, what they will ask you? Write down all 4 quantum numbers of valence electron of potassium. Valence electron of potassium. Who's that? Valence electron of potassium. So now we can go potassium. Atomic number is 119. What we can write? 1s2, 2s2, 2p6, 3s2. Can write 3p6, then 4s1. As per the, what we can say? Written like this. 4s1 is the. Now valence electron is what? It's a 4s1 is the valence electron. I'm writing 4s1. Now I can write this is belongs to n is equal to 4. This belongs to what we can say L is equal to 0. When L is equal to 0 means what? They have the only one orbital. I can write that Mi is equal to 0. Now I am writing EMS is equal to plus or minus 1 by 2. Look at the option what they are going to based on that we can write it. That means this is the 4 possible quantum numbers for the valence electron of potassium 4s1. Rubidium, same thing. Rubidium means what? Only this only going to change n is equal to 5. Cesium n is equal to 6. So remaining will be 6. This is what in examination point of view they will ask you. And one more question in exam what they will ask you. The question is, the compound of vanadium has. The compound of vanadium has compound of vanadium has magnetic moment. Moment is 1.734 magneton. I can write here VCL means. Okay, the chloro compound of vanadium has the magnetic moment is 1.73 Bohr magneton. Find the formula of the compound. What is the formula? Option A which is given VCl3, option B VCl4, option D VCl, option VCl2. How to find out? It is simple. This is the compound anyway. That means Vx plus what? XCl minus. Like they're only going to ionize that. So I want to find out this X value is easy. Now what they are given? Magnetic moment is what? 1.73. Okay. First I am going vanadium. What is valence electron of vanadium? You should know as D3S2 is the valence electron of vanadium. Now what they are given? The Bohr magneton is what? 1.73. 1.73 means what? Root 3. That means they are given as root of n into n plus 2 is nothing but is what? Root 3. And root 3 means what? The vanadium ion has only one unpaired electron. That means I should remove that. That's all. Vanadium plus 4 ion which has D1 system, the magnetic moment is what? Root 3. Therefore the X value is what? Plus 4. Therefore what is the answer? That's all. This is what they will ask in the examination. Another important part. So what is that? The case of, just I want to talk about that. Now, very simple thing. I will discuss with that as, listen, psi and psi squared. Psi is called wave function. The psi squared is called probability density. That means they will say psi is depends on, how do we can say, psi r, I can write psi theta and phi. This talks about the radial part. This is called, what we can say, angular part. So this radial part depends on n and l. Angular part depends on m and l. This talks about what we can say that size, we can say that. This talks about that orbital angle. And psi has no physical significance. So how we are going to say? Very simple. Then draw for that result. Psi for 1s versus r. Look at this, I am getting like this. Now when I am going for psi for 2s, that's all. This is r. What is this called? Node. So what is node? Node means the where the probability of finding electron density is 0. Because when r is increases, the size keep on decreases. This is the point is what? When r at particular distance, psi becomes, what we can say that? 0. That means the where the probability of finding electron density is 0 is called node. But what I am trying to say here, look at this. Psi, that means probability means what? You should have 0 or positive value. But look at this, I am getting negative value. Therefore, psi has no physical significance. But psi squared has physical significance. When I square up this, negative becomes what? Positive. What is psi squared? That means the finding electron density in a particular, what we can say, particular point in a 3-dimensional. That is called psi squared. Look at this. Now I am going to explain that. In case of psi squared versus r, I am going that 1s psi square versus r. Now look at this 2s psi square keep on going back, and this will be, that's all. This point is called, what we can say, node. To find out the node, very simple, go with that n minus l minus 1. Or we can go with that as radial node. So what is radial node for? 1s means n minus 0 minus 1. Therefore, it has no node at all for 1s orbital. Now 2s if we take radial node, what is that? N is equal to 2, 0 minus 1, therefore which has 1 node. Now look at this for 3s. I'm going with that psi squared versus r. Now you have, this is 1 point node, this is node. You have that node. This also is what node. You have for 3s orbital, you have 2 nodes are there. 1s orbital, 0 node. 2s orbital, 1 node. 3s orbital, 2 nodes. When the number of node increases, the electron is away from the nucleus. So which means that the 3s is higher energy level than 2s. The 2s is higher energy level than 1s. Because when more node is there, the electron is far away from the nucleus. What is node? Node means the probability of finding electron density is 0. If we want to draw in the representation like this, look at that. I can say as this is positive charge. This we can talk about as 1s. This is nothing but as 2s. This is 2s. So this I can talk about is 1s. This is what as 2s. This is called this part is called node. That means the way the probability of finding electron density is 0. We can say called radial node and angular node. S orbital is spherically symmetrical. Therefore, we can talk about that as a angular node is nothing but N. Therefore, P has 1 angular node, and we can say B has what we can say 2 angular node. Don't forget about it. Angular. Therefore, we can able to find out n minus L minus 1 L then n minus 1. This n minus L minus 1 gives the number of radial node. L which gives number of angular nodes, the n minus 1 which gives total number of nodes for the particular orbital. And last will be Einstein photoelectric effect. Look at this. In Einstein photoelectric effect is nothing but this. Just I'll draw in simple explanation. Let us take like this. Here metal is there. Here I can say as metal. This is connected with one battery. I can go with that as. Now, incident light is fall on the metal. Look at this. When the incident light is fall onto the metal, the electrons are come out of the metal surface. The electrons are called photoelectrons. Electrons are called photoelectrons. That phenomenon is called what? Photoelectric effect. The electrons are comes out from the surface of the metal, nothing but ionization energy of the metal. That means what they trying to say, the condition of the photoelectric effect, the incident light should possess what we can say the minimum energy to remove the electron. That means what they're trying to say, I can say this is E, this is nothing but what? E naught. This E naught is called work function. The electron which is strongly attracted by the nucleus. So to remove that, obviously the energy should possess greater than or equal to what? E naught. Then only what? Electron will be removed from the surface of the metal. Now I can say E, if it is greater than E naught, electrons are removed. Or if it is E is less than E naught, no photoelectric effect. And very important condition. Kinetic energy of photoelectrons depends on frequency and not dependent on intensity. A number of photoelectrons comes out depends on intensity. Please keep it in your mind. The equation says that E is equal to E naught plus, and now we can write that as E is here the energy possessed by incident light. E naught is the work function of the vector. This is kinetic energy of photoelectron. Therefore, we can draw that. This frequency. Now, same. So the kinetic energy of photoelectron depends on the frequency, and kinetic energy of photoelectron is not depends on intensity. From this, they may ask you, keep in your mind that the CCM is used as a photoelectric cell. Why? Because CCM has lower ionization energy. So different metal will have different work function. All metal is not having same work function. Please keep it in your mind. So this is about the atomic structure. Thank you so much. Bye.